Okay, Assalamualaikum. Hello everyone. Okay. Okay, Assalamualaikum and very good morning everyone. Selamat Hari Raya, maaf saya dan batin. Semua kita diberkati pada pagi ini. Good morning everyone. Okay, apa khabar tuan-tuan semua? Let's give a few moments for the rest to come in. Then we will start officially and thank you for your patience. Okay, baiklah. Mari kita beri masa sebentar untuk semua masuk ke dalam room webinar kita pada hari ini. Terima kasih menunggu ya. Okay, sementara menunggu yang lain. Semua mendengar ke suara saya kat sini? Kalau dengar boleh type 1 dekat ruangan chat. Okay, semua dengar ya. Okay, terima kasih menunggu. Sementara menunggu yang lain boleh chat dulu. Dan kenalkan diri anda daripada company mana dan juga position. Okay, boleh kenalkan diri sementara menunggu partisipan kita yang lain masuk ya. Alright, semua dengar. Terima kasih. Okay, boleh kenalkan diri sesiapa daripada company mana. Okay, Cik Darwis Mahmud. Okay, terima kasih Cik Darwis kerana join session course kami pada hari ini. Okay, alright. So, mari kita teruskan. Okay. Okay, alright. Okay, Cik Khairul Amin dari Isuzu. Pekan. Oh, replace Cik Nazma. Okay, Cik Khairul Amin. Okay, Cik Haris dari Property Co and Building. Oh, manager, thank you Cik Haris. Okay, baiklah. Okay, first of all, welcome to iLearning Asia Webinar Series 2020 and thank you for joining us today. Let me introduce myself. My name is Ayu Muhammad and I will be your host for today. Seperti yang semua sedia maklum, disebabkan COVID-19, semua kita disediakan dengan new normal iaitu virtual class learning. So now here we are into the online class training. We hope you enjoy all our webinar free training session for our technical course, predictive maintenance. Okay, if you have having difficulty hearing us and or you see a blank screen, please click the reconnect button at the center of the page, yeah. Morning, Miss Boon. Miss Boon, sorry. Miss Boon. Hi, Mr. Raja. Okay, Assalamualaikum. Cik Mosan dari Jackson Pond. Okay. Okay. Okay, let's us continue, yeah. Okay. Now I would like to do some briefing for you. The briefing is the webinar session is 40 to 60 minutes. Should we cover 5 minute opening, 40 minutes training session, 50 minute Q&A session. Here is some guidelines. To chat, simply type your message and hit send. Your message will appear in the chat box. Okay, boleh chat box kat belah kanan tu dan juga bagi soalan. For request, please type your question then change from the chat mode to the Q&A mode and hit the send button. Dan jika anda nak bercakap dengan trainer untuk soalan yang lebih complicated, boleh request the speak button ya, yang for the right hand tu yang ada raise hand punya logo kat situ dan kita will approve. Okay, for today we will discuss and learn topic about predictive maintenance from our best trainer Encik Suhaimi Muhammad Sudin. Okay, apa khabar Encik Suhaimi?
Baik, Alhamdulillah.
Okay, Encik Suhaimi sihat ke?
Ya, sihat. Baik.
Okay. Okay, Encik Suhaimi adalah degree in mechanical engineering. Okay, UiTM Malaysia, certified MIA 2, certified MIA 1, vibration analysis instructor. Okay. Okay, baiklah. Tak apa membuang masa lagi, saya akan serahkan kita punya webinar pada hari ini pada Encik Suhaimi. Okay, dipersilakan Encik Suhaimi.
Okay, terima kasih Ayu. Assalamualaikum and very good morning. Mr. Mohsin, Mr. Bunsing, Mr. Raja Mugilan, Engineer Haris Fazilah Hussein, Cik Nazman, Cik Darwish, Cik Fuad, Wong Melin, Darwish, dan semua yang ada dalam chat room ni. Okay, first and foremost, thank you very much that you could join this session. So this is about preventive maintenance. Okay. Please feel free to share anything at the chat session by typing your comment there. Okay, or you could raise your hand. Okay, and we will give the permission for you guys to speak. Okay. Let me introduce myself first. My name is Muhammad Suhaimi. My specialty is more on asset management. Okay, asset management, whereby my specialty is more on the RCM, which is reliability centered maintenance, preventive maintenance, predictive maintenance, vibration monitoring, and whatnot. Okay, so if you do have any question, you can ask me instead of this preventive maintenance topic. You also can ask anything about asset management, vibration monitoring, thermography, inspection and maintenance, anything. Okay, instead of preventive maintenance. Okay, so for today, this topic will not cover deeply in preventive maintenance. Only the basic idea and also what is the current practice in preventive maintenance nowadays, and you can apply it in the manufacturing sector, oil and gas, power generation. It can be applied. Okay, so mostly we see on the how preventive maintenance will help us. Then does this preventive maintenance is actually the best method in maintenance? Okay, that is a big debate in industry. Okay, so okay, okay, can you see the slide, gentlemen? If you can. Okay, the video start, Mr. Mohsin. Still start or? Okay, if you have a problem viewing this video, you just type in the comment section, okay, and then we will try to rectify it. Okay, so everybody can see the slide? Okay, good. Okay, so when talking about maintenance, everything needs maintenance. Okay, if we talk about machine, car, road, pet, okay, even human being, we need a maintenance. Okay, but the approach is of course quite different. And the biggest paradox in maintenance, okay, this is the biggest paradox in maintenance, whereby it's broken because we didn't work on it, and it's broken because we did work on it. Okay, so this is the paradox. And in preventive maintenance, this is always being a problem for decades. Okay, when we take an easy example, when you change the bearing, okay, you change the bearing, there is 11 nuts when you disassemble the bearing. When you assemble back, you probably only put 7 or 8 nuts to your machine. So you leave by probably 3 or 4 nuts behind. Okay, so you do not know how to fix it again. So this will, you know, this is the maintenance problem whereby it's broken because we did work on it. Okay, there was a classic example. One of the MNC company, they shut down and they changed the bearing. So what happened? They changed the bearing and put back the lock nut inversely. So what happened when they start the fan back, the vibration shoot up to 14 millimeter per second. Then they need to stop the plant back, and they lost about 2.1 million per day. Okay, that is what the paradox is all about. It's broken because we did work on it. But it also can be it's broken because we didn't work on it. Okay, so it's a paradox. Paradox is something like you cannot do something irony in one time. Like I ask somebody to, sir, please sit down and stand up now. Okay, so that is paradox. Okay, so this is a big discussion in the maintenance, because we actually want to, you know, continue running the machine, or we want to stop it and do it the PM. Okay, so that is a big discussion. Okay, so this slide is also important, although this is a very basic one, but this is a very important slide, because this slide will guide you to your maintenance philosophy. Okay, for the gentleman inside this room, where in a position of the division of policy making, this is very important, because when you come to the maintenance, you need to have a very clear picture. What is the maintenance philosophy of your plant will be? Okay, meaning that you need to declare, are we going into predictive, or you want to go to proactive, or you are 100% preventive maintenance? Okay, so you need to declare and proclaim first inside your philosophy. And if you want to hybrid it, we want a little bit of proactive, you want a little bit of preventive and predictive. How many percentage of this maintenance strategy will come into your maintenance philosophy? Okay, because sometimes your subordinate will confuse, because they have a lot of idea in predictive maintenance, but your philosophy is more on preventive, no more predictive, only preventive. Okay, so your subordinate will probably confuse what to do. Okay, so the best is you come up with the a good maintenance philosophy. Okay, so I will clarify a little bit about this maintenance strategy. The first one is the reactive maintenance. This is a old-fashioned maintenance way, how you do the maintenance. So reactive is a firefighting thing.
Cik Suhaimi?
Ya.
Okay, kita berhenti sekejap sebab ada yang gangguan yang blank picture.
Ya, ya.
Okay. Okay, kita tekan panic button dulu dan kita reconnect. Okay, sebab macam kita ada group WhatsApp, ada ramai yang trouble ni. Okay, so kita restart sekejap ya.
Okay, baik.
Sekejap, tanya dulu. Okay. Okay, Cik Suami.
Okay.
So semua ada yang blank lagi? Okay, kita akan masukkan link YouTube kat sini pada siapa-siapa yang blank. Okay.
Okay, everybody okay? Ada yang blank lagi? Okay, can we continue, Ayu?
Cik Suami,
Yeah.
silakan.
Okay. Okay, there is one question from Mr. Osman. How you define the proactive and predictive maintenance? Okay, let's start with reactive first. Okay, so reactive maintenance is firefighting. This is everyday job. In the morning meeting, you got a lot of corrective maintenance job coming from operators. Okay, so this is reactive thing, firefighting. Okay, then this is old-fashioned way in doing maintenance. Then people realize that reactive maintenance is not good for company. It costs a lot of money. Then people start to migrate into preventive maintenance. Okay, so in the preventive maintenance, people start to doing things by period of time. Manufacturer come out with their 1AM, say that you need to change the oil every 3,000 hours, you need to change this and that, you need to do this and that every 4,000 hours according to the time. Then people still do not satisfied because preventive maintenance still give you some difficulties in terms of cost and manpower and man hours. So what happened? People try to create something new. They go into predictive maintenance or condition-based maintenance or prescriptive maintenance. Okay, a lot of name of predictive maintenance nowadays. But still, people want to improve, and nowadays they go until proactive maintenance. Okay, so this is a basic for maintenance strategy. Okay, Mr. Mohsin asked about why it called firefighting. Okay, because you so reactive. You do not know where the when the problem will appear. Okay, usually the problem will appear in the middle of the night. Okay, just like a fire. Okay, the fire engine, the fireman working 24 hours a day because they do not know when the problem will start. Okay, so this is why firefighting. In the middle of the night, anytime operator or plant will call you, say there is a problem in the plant. So that is reactive or corrective maintenance. Okay, so that's why we call it firefighting. Okay, so this is the 4 strategies for those managers out there in this chat room. I mean, you need to realize that these 4 strategies will impact your plant or your factory or your company very much. Okay, of course, in asset management, these 4 things you need to have a proper explanation in the documentation, especially when you try to get the ISO 55,000. Okay, for those who are interested in ISO 55,000 asset management, you could ask the question also regarding the on the maintenance part and also some of the life cycle of the equipment. Okay, okay, so then people go for preventive. As I said just now, preventive is all about you change this and there by follow the period of time. This is what a lot of manufacturers do. They send you the equipment with the manual, and the manual will state that you need to change the oil every 3,000 hours and a lot of things there. Then people go predictive. Okay, when we're talking about predictive, this is a very important thing. Predictive is not something. It's not a method. You try to predict the lifetime of equipment. Okay, that is not predictive all about. Predictive maintenance is a type of maintenance whereby you try to predict the problem of the equipment. Okay, so we need to be clear on that. Because if you try to predict the equipment lifetime, there will be a big problem. There is no way you try to predict the equipment lifetime using the predictive method. For those who are familiar with vibration monitoring, there is no way you could predict when the equipment will fail using vibration monitoring. you can predict the problem or the symptom of the equipment by using vibration monitoring or ultrasonic airborne. Okay, so that is about predictive maintenance. We use some procedures, we use some standard, we use some equipment in order for us to predict the condition of the equipment or the problem of the equipment. Okay, let's take one example of predictive maintenance. We can do vibration monitoring on our rotating equipment so that we could predict what is the problem of the equipment. Either it's a bearing problem, the component bearing problem, or you have a electrical motor problem. Okay, so this is what vibration monitoring do. In a boiler, we can perform the replica test, okay, iris test to see the thickness measurement of the boiler tube. Okay, that is what so-called as predictive maintenance. Okay, and the last one is a proactive maintenance. Okay, the proactive maintenance is more than predictive maintenance, whereby you are away. Do we have a connection problem here? Nick Farhan, Farhan. Are you? I need you to see Mr. Farhan. There is a connection problem.
Okay, Cik Farhan boleh refresh reconnect button ya dekat atas tu. Boleh tekan kat situ, nanti dia akan okey.
Okay, so proactive is another level, okay, whereby you kill the symptom immediately, but it needs to be supported by predictive method. Okay, let's say you have yeah.
Cik Sami ada soalan daripada Cik Mohsin, sekejap ya. Dia tanya, why does it call firefighting?
Yeah, I already answered that
Oh
Mr.
yeah,
Mohsin,
okay,
question
sorry.
just now. Yeah. Okay, you just type anything. Okay, you can just type anything, and I will stop and answer your question first. Okay, before I proceed. Okay, so proactive maintenance is more than that. It's another level, but proactive maintenance usually been supported by predictive maintenance. Okay, as an example, you have a set of pump and electrical motor. Then by using predictive maintenance vibration analysis, probably you get a symptom of misalignment, a mild misalignment. But this misalignment doesn't affect your machine very much. The function is okay. The performance is totally 100%. The bearing do not give you any symptom of high temp, but there is a little bit peak show that there is a mild alignment problem. So you immediately stop the equipment and perform the alignment procedure for the pump and also motor. Okay, so that is proactive maintenance. You kill the symptom immediately. Okay, but the symptom is coming from the predictive maintenance. Okay, so that is a proactive maintenance. Another example of proactive maintenance is if you have a lubrication system whereby the system is totally okay, totally alright, the functionality, the performance is tip-top, okay, but by predictive maintenance, you find out that the oil inside your reservoir or gearbox or whatever have a lot of particulate, okay, it's not so clean. So what you do, you filter the oil, okay, so that is a proactive maintenance, okay. So that is 4 basic maintenance strategies. Okay. So any question regarding this basic maintenance strategies? Okay. You can just ask or type your comment. Okay. The next slide. This is a classic PF curve. Okay? Classic PF curve. Whereby it will show you the remaining life and the operating hours of your machine. Okay, but nowadays they develop a new curve whereby there is a DIPF curve, which is also involve D for design, I for installation, okay, and being integrated into this PF curve. Okay, so what happened in this PF curve, progression of failure curve? We can see the four maintenance strategies just now. Okay, whereby the first one is run to fail, which is the firefighting reactive. Then you have preventive, predictive, and also proactive maintenance. If you focus your equipment in the proactive section, meaning that you have a lot of proactive maintenance regime, what happened, you could always let your machine at the 100% remaining lifetime. Okay, so remaining life is very high. But if you start to go for a lot of run to fail, you can see the remaining life is around 30%. Okay, so this is not good. Okay, and another one is preventive. If you apply a preventive, it's around 50 to 60% of remaining lifetime. Okay, so there is a question from Engineer Haris. What is the percentage at each stage? Slightly better is you can highlight the percentage level of this stage. Okay, percentage of what is this of remaining life. Okay, as I said just now, if you go for run to fail, okay, if you go for reactive maintenance, okay, so you meaning that, okay, we take an example, run to fail or reactive maintenance. What is among the method of run to fail reactive maintenance? When you use your 5 cents, okay, you use your 5 cents, like you touch the electrical motor and it's too hot to touch. Okay, a lot of supervisors and technicians, they use this kind of method. They go around for a round check, then they touch the bearing of the body of the motor, and they say that this is too hot to touch. If you come to that level, means that you are actually have only 50% of your remaining lifetime, the equipment remaining lifetime. Okay, so that is not good. Okay, because because when you find out that your machine or equipment is in a problematic stage, you want to plan it, and some of the equipment you cannot get the component at your site in 20 hours time. Probably the delivery take you 1 month. Okay, then you need to prepare for the plant shutdown. Okay, in some sector like power generation, you cannot just stop your plant. Okay, so there is a 50% remaining lifetime if you go for run to fail. Okay, but if you go for predictive or proactive, there is a good chance of around 80 to 100% remaining lifetime. So you know that your lifetime of the equipment is good, about 80 to 100%. So you have a ample of time to get ready for shutdown, to order for the equipment, to ready for the manpower. Okay, so this is the whole idea of the progression of failure, PF curve. Okay. Okay, so do I answer your question, Mr. Haris? Okay. So any other question about this PF curve? Okay, there are also a thermography. If you can see one of the predictive maintenance, there is a thermography. Okay, for some, probably there is a electrical guys out there. Thermography is very useful for you. Okay, Mr. Haris, no. Okay, percentage of what is this? Okay, let me read your questions one more time. What is the percentage at each stage? Slightly better if you can highlight the percent. Okay, there is no specific percentage to say, but of course there's a whole lot of other technical papers that you can read to show what is actually the specific percentage for each stage. But this slide only gives you more or less the idea what is the remaining life for each of the maintenance strategies. Okay. Okay, Mr. Haris. If you have, okay. The estimation is like that. If you do not perform preventive maintenance and above, meaning that preventive, predictive, and proactive, you will live by 50% and lower the remaining life of your equipment. Okay, so the idea is to set up your maintenance regime within preventive, predictive, and proactive only. no run to fail. If not, the remaining life will stay at below 50%. Okay, so that is just estimation. Okay, so Mr. Haris, if you want to discuss more later on, probably you can contact me. Ayu will give you the contact of Ayu also can facilitate you on this. Okay, any more question? So just can type it. Okay, this is a maintenance characteristic. What happened? A lot of maintenance personnel, they focus on repair focus, which is when it's come to problem and defect, they only fix it. They do not have the mentality of improve it. Okay, so preventive maintenance must avoid this kind of thing. Okay, when you perform the preventive maintenance, you must have the idea of reliability oriented, not just doing the work because this is the PM. I need to just settle the PM within the mentioned time, within the period, and that's it. Okay, that is what I think is quite a bad way to do preventive maintenance. We will see more on preventive maintenance later on. Okay, so this is the idea. Okay, Ms. Haris, I will answer later on your questions. Okay, so this is what, especially on the engineer level, manager level, okay, and the policy maker level, to have in their maintenance philosophy. Okay, whereby you need to have reliability focus, not just a repair focus maintenance. Okay, so instead of fix it, you need to improve it. Okay, firefight, you need to predict, plan, and schedule. Okay, instead of being a tradesman, you need to be a business team member. Okay, this is quite interesting, because if we're talking about tradesman, okay, tradesman will do everything. Okay, it trades everything. Okay, but if you focus on business team member, you will try your best to secure your business. Okay, so this is quite good. Another thing is everybody try to manage defects. In the morning meeting, everybody actually try to discuss and how to manage our defect. Every department, every section, they only try to manage the defect, not to eliminate the defect. Okay, so this is an important thing to ponder. Another thing is to reduce maintenance costs. Sometimes a lot of when it comes to the budget challenge time around August or September, finance will try to reduce the maintenance cost. Then come the senior manager said we need to reduce the maintenance cost. That is so, repair focus minded. What you must do, you actually focus on how to increase uptime, how to increase the reliability, how to increase the availability. Okay, so that is more, that is actually better if you have that kind of mindset. Okay, so this is something for managers, engineers to think. Not just go for repair focus, but you need to start for reliability focus. Okay, this is KPI among the popular KPI in the industry. Okay, like emission downtime, repair and maintenance cost, breakdown occurrence, mean time between failure, mean time to repair. Why this is very important? Because this is the measure of your PM. Okay, you create a maintenance regime. You want to know whether your maintenance regime is good enough, is successful enough or not. You need to have something like this. You need to have a KPI. Okay, so some of the KPI probably do not relate to your industry. Okay, some of the KPI you can use in your industry. Okay, let's take one popular KPI whereby mean time between failure. Okay, this is the classic KPI that a lot of industry use. Okay, so you try to measure the mean time between failure of your equipment. Okay, so the higher MTBF is the better. So when you introduce the PM, you want to see the MTBF going up. Okay, then there is another failure. You come back and do some analysis, you do RCA and so on. Then you introduce a new set of maintenance regime. Does this new maintenance regime, okay, give you higher numbers compared to the previous one. Okay, that's how you measure your PM as an example. Okay, this is come from DuPont. Okay, this is come from DuPont. Okay, you can see the prediction of failure, the last one, the prediction of failure. This is a lot of KPI from DuPont, but I want to emphasize or stress the last one, which is prediction of failure, whereby the PPM work, preventive maintenance work, more than 20%. And PPM schedule compliance is more than 90%. Okay, this is what, this is something that you need to be clear of, especially for your subordinate. Okay, the KPI that need to be measured in the percentage of how much PPM work need to be done. Okay, it do not include the predictive here. Okay, but somehow you can put it here. Okay? So how much the preventive work, how many percentage of preventive PM, probably more than 60%. Then you have predictive more than 20%, emergency probably only 5%. Okay, that is why I'm talking about the maintenance philosophy just now. Okay, so all this KPI is actually extracted out from your maintenance philosophy. Okay, this is the world-class value of the KPI, whereby your availability must go 90% or above. Okay, your performance is 95%, your quality is 99%, and the OEE, overall equipment effectiveness, is 85%. Okay, this is world-class value. So if your bosses ask, can we increase the OEE more than 85%, boss? The OEE is the 85% for world-class value. So we are in the world-class level. Okay, so OEE, world-class value of OEE is 85%. Okay, so this is KPI mostly coming from the manufacturing industry. But
okay,
if you are, yeah.
Okay. Sorry, kita ada soalan pada group WhatsApp kita, pada Encik Hazli. Okay. What is the best to set up baseline on MTBF and MTTR? Is based on historical data or best practice to start with baseline?
This is from who?
Hazlin.
Hazmin.
Encik Hazlin. Hazlin.
Hazli. Okay, Encik Hazli. So,
Hazlin.
Encik Hazlin. Okay.
Okay.
What is the best MTBF and MTTR? Okay, later on we will see how to produce, how to write or produce a good PM regime or a good maintenance regime. Okay, so the process is actually, I can say this is a never-ending process, because this year probably you have 4 new defects that you found. Compared to last year, there is only 1 defect. Okay, so by doing some analysis, you probably want to renew your maintenance regime. Means that each year your maintenance regime need to be renewed. Okay, there is no such thing. There is only 1 maintenance regime for 25 years of the plant last time. There's no such thing. Okay, the maintenance regime need to be reviewed every year or every 2 years at least. Okay, so that you can increase your MTBF and your MTTR. Okay, to give the specific number, it's quite hard because the industry is different. We take it as an example, a simple crusher or pump in the harsh environment like a fertilizer environment. Okay, the bearing probably would last only 12 months, okay, compared to pump in a clean environment, okay, whereby it could it could go for probably 3 years to 4 years. Okay, so the idea is you must renew your maintenance regime. Okay, analysis, we will see later on how you analysis all these maintenance things, all these risk based maintenance. Okay, we'll see later on. Okay, as long as you have this kind of thing, you have the committee, you have the team, okay, to renew this thing, you are in good position. Okay, so to say an average of MTBF or average of MTTR is quite difficult. It's actually depend on your industry and how proactive you are in renewing your maintenance regime. Okay. Okay, this is the top 3 KPI measurement for any industry. The first one is work order, which is schedule, completed, and past due. How you gonna measure it? Okay, you have a schedule maintenance. Okay, how many percentage that you fulfill it, and so on. And another one is estimated time versus actual time spent. And last one is machine downtime versus uptime. We'll see the example later on. Okay, there's a question from Mr. Muhammad Asha. With the economic effect of COVID-19, there is a pressure to focus on costs rather to follow through correct maintenance regime. Yes. Okay. That's why we go through RCM process. Probably, Mr. Asha, you're familiar about the RCM, reliability centered maintenance, whereby we try to slash out a lot of unwanted maintenance things, maintenance tasks inside your maintenance regime. Okay, we will see later on how this RCM will help you. Of course, I totally agree with you. Okay, it's not because of COVID. Okay, only this year COVID affect maintenance. Okay, last year a lot of things also actually affect the maintenance cost. Okay, it's not just this year. Every time maintenance being projects as something that, you know, liability of the company. Okay, some of the finance manager, they see maintenance is actually a waste of money. Okay, so it's not just COVID-19. I think for the past probably 20 years, maintenance always been seen as waste in a company. They try to reduce a lot of cost for the maintenance. Okay, so no worries. Okay, we will discuss a lot of RCM on how you can cut the cost of the maintenance itself. Okay, this is work order analysis, whereby you have scheduled jobs, completed jobs, okay, and you have the compliance score and the total completed jobs compared to the scheduled jobs. Okay, you can use this to analyze the job inside your maintenance personnel or inside your maintenance department. Okay, this also the same. Okay, you can see date work, estimated actual variance. Okay, all of these things. Okay, this is staff productivity summary. I will not touch it in detail, but just to give some idea to you guys. Okay, this is another KPI, which is machine downtime versus uptime. Okay, so you have the KPI of 16 hours per month. Okay, some of the months like January, May, June, okay, they go beyond the 16 hours. Okay. Something like this, you need to, put it at a place that everybody can see. Okay, probably in the pantry, at your fridge door. Okay, so everybody can see every day. Okay, so that they start to appreciate it. You need to do that. As an engineer that have a lot of supervisor, technician below you, as a manager especially, okay, you need to try to put it in a wall that everybody can see it every day. Okay. Okay, so this is a workshop. Okay, as we discussed just now, we have breakdown, preventive, predictive, proactive. Okay. So we take our car as an example because it's very close to us. if we take a machine in a plant, not so close to us, but our car is very close to us. So how about we have some analysis session, okay, on how we actually maintains our car, okay, how we maintains our car. Okay, we start with engine, okay. So for engine, okay, so if possible, can you type here in the section area, in the comment section, what type of strategies, either breakdown, preventive, predictive, or proactive, is the best for your car engine? Okay, so for your car engine, do you think breakdown is the best, preventive, predictive, or proactive? Okay, then the lube oil of your car, which is the best, breakdown, preventive, predictive, or proactive, and so on, paint, aircon, and the braking system. Okay, let's go to the first one, engine. This include all the belting system inside it, okay, the spark plug, okay. Okay, so the engine, if we buy a car, of course, there will be preventive maintenance that come with the car. Every 10,000 kilometers, you will go to workshop or service center, and they will change the oil. Probably in 70,000 kilometers, they will change the belt. Okay, so that is preventive maintenance for the engine. Okay, but do we really need to change the belt, as an example? Okay, every, let's say, 70,000, do we really need to change the belt? Okay, what happens if the condition of the belt is still good? Okay, so it is a waste to change the belt at that moment, at that 70,000 kilometers. Okay, so we do not perform preventive maintenance if we go for the inspection of the belt. Meaning that we only change it when we think the condition is bad, or the condition is not, the condition of the belt will not perform its required function. Okay, that's only we change. That's the time we change the belt. So we move from preventive to the predictive or condition based. Meaning that we will save a lot on that. Okay, because the preventive maintenance say, the service center say that you need to change every 70,000, but the condition is still good. So you try to prolong it another 5,000 probably. Okay, so there is no more preventive maintenance there. So you actually go for predictive maintenance. Okay, another example, we take a lube oil. Synthetic oil, the service center will change every 10,000 kilometers. But what happens if the oil is still good? Okay, but the chassis or service center will always change it every 10,000 kilometers for synthetic. Okay, so the question is, what if the condition of the lube oil is still good? Can we prolong it? Yes, we can always prolong it because it's still good. Okay, the oil engine is still good, so we can always prolong it. So we actually move the maintenance regime or maintenance strategies from preventive to the predictive or condition based. So by doing this, we save a lot actually. Okay, for our car, probably the saving is not so much, but for your plant, the saving could be a lot. Why? Because you have a whole lot of lube system in your plant. So if you go for predictive maintenance instead, go for preventive maintenance, you will save more. Okay. And what if this lube oil fail prematurely? Let's say the LC said 10,000 kilometers, but it's actually failed at 7,000 kilometers. Okay, so you need to change at 7,000 kilometers. So it is not just to prolong, the idea of predictive or condition based is not just to prolong the component lifetime or equipment lifetime, or the maintenance period, but it also will give you the good indication and symptom if the component fail prematurely. Okay, so this is all about the predictive maintenance. On lube oil, probably you want to change from preventive to predictive maintenance. Instead of change 10,000 kilometers, you start to inspect your quality of the oil. Of course, a whole lot of method on inspect and see your quality of your lube oil. Then, can you perform the proactive maintenance for your lube oil? Yes, you can also go for proactive maintenance. Okay, probably you want to use a good filter, okay, with a lower micron. Okay, this will, this will trap a lot of small debris inside your engine and protect your engine. Okay, so this is the idea of the maintenance strategies that need to be inside your maintenance philosophy. Okay. Okay, this is RCM, which is reliability centered maintenance. Usually it comes with a 7 question. I include 1 question inside, which is what is the mission last time, but conventionally RCM is actually 7 questions. Okay, what are the function, what if the asset fail? Okay, that is the 7 question. I will not touch every and each questions in detail. Okay, but I will discuss on the idea. Okay, so this is how RCM will help you come up with the maintenance regime. Okay, so you can see there's a whole lot of column there. Okay, the first column is equipment, component, function, functional failure, failure mode, failure consequences. Okay, this is the important column whereby the predictive maintenance and preventive maintenance. Okay, how this RCM works? Of course, first you need to explode everything inside your equipment. Okay, the components. What I mean is a component. Okay, so in this raw water pump, this is Freitag pump S340. So the component is motor bearing, motor windings. Okay, the motor is a Siemens, coming from Siemens. You have coupling. Okay, you have pump bearing. You have pump seal, shaft, and base. Okay, this is the component. The next thing is you need to analyze how this component gonna fail. Okay, so you have this failure mode of each component. Okay, first of course there is functional mode, which is the functional failure mode. Okay, what is the how this equipment will fail functionally. Okay, but that is not so important. But the important part is how this to analyze on how the failure mode of each equipment. Okay, so we take one example, bearing failure. Okay, if there is a bearing failure of this equipment, the production will stop. There is a lot of downtime that will lead you to the less profit. Okay, the first thing in your mind, you must think how to have a predictive method for the bearing failure. Okay, you know the bearing will fail. So what is the best predictive method for the bearing failure? Okay, so for the bearing failure, you can go for vibration monitoring or ultrasound airborne, let's say. Okay, so you have that predictive maintenance. Okay, let's say if you do not have the predictive maintenance way or method to do it, only then you move into preventive maintenance. Okay, in this case, you can see at the preventive maintenance column, there is seal change every 3 months. Okay, there is no way we can inspect a seal. There is no way we can do predictive maintenance on seal. Vibration will not pick up. Other method of predictive also will not pick up the seal problem. I mean, at the symptom stage, if you already see the oil coming out, there is a leakage everywhere. There is already at the failure stage. Okay, we are talking about predictive stage. There is no way we could have a predictive method or condition-based method to perform on the seal. So only then we move the seal from the predictive to the preventive maintenance. If we still have a method for predictive, we include inside the predictive column. Okay, so by doing this, we could rule a lot of preventive maintenance job. Okay, so let's see the question. Oh, suara hilang.
Okay. So this is the way RCM work. Of course, there are a whole lot of steps to do this, but this is what more or less the big idea of RCM. So the RCM is actually some sort of tools that you use to analyze or to renew your maintenance regime. Okay. Any question for this slide? Probably you're not clear or anything for me to clarify. Okay, let's take another component, which is base. Okay, base usually will fail, the failure mode of base will fail through base corroded. Okay, so base corroded, how we do it? We go for visual inspection. Okay, we can go for visual inspection. We can see we can perform the visual corrosion inspection for the base. So they need no need for preventive maintenance. Okay, this is another example of the RCM. Okay, so what is the functional failure? What is the failure mode? Okay, then you analyze each mode, how you're gonna perform it predictively on the condition base. Okay, if there is no such thing, only then you move into the preventive maintenance. Okay, this is more or less the template how you perform the RCM, where you have a whole lot of equipment. You have a circuit breaker, then the component inside it. Okay, what is the failure, functional failure, failure mode? Okay, then what is the best predictive maintenance available? If not, you move into the preventive maintenance. Okay, this is FIMIA. Okay, this is another way or another tools. Okay, that actually will support RCM. Okay, it's called FIMIA, failure mode and effect analysis. It will support the RCM and it also will support your PM, preventive maintenance. And if you want to use it for RCA, root cause analysis, it's also a good tool. Okay, probably some of you are already familiar on this FIMIA. Okay, so what happened in FIMIA? You have a function or process step and you have a failure type. Okay, so this is the failure type you're talking about, the failure mode. Okay, still remember on the RCM on the failure mode column. Okay, so this failure type. We take as a simple example. So this is a car example, still a car example. So the failure type is a flat tire. Okay, the failure type is a flat tire. So what is the potential impact? Potential impact will stop the car journey, drivers and passenger, and they will stranded. What is the severity? The severity is 10 out of 10, worse. Okay, then the potential causes is punctured. OCC is occurrence or likelihood. Okay, so there's only 2, meaning that it's not frequently happen. Okay, so OCC is occurrence or likelihood, which is how frequent is this likely to occur. Then the detection, how you detect it? Tire check before journey, while driving, steering, pulls to one side, assess noise. So the detection is easy. How easy to detect the problem? Okay, so the number is 3, meaning that it's easy to detect. Okay, so you multiply everything 10 times 2 times 3, you get the risk priority number 60. Okay, you have the risk priority number 60. Okay, the idea is to bring down the RPN. Okay, now it's 60. You try to bring down the number 60 to a lower number. Okay, so what you do, you introduce the recommended action. So in this case, the recommended action is to carry spare tire and appropriate tools to change the tire. So who will responsible, or the car owner? You have a target date, you have the action taken. Okay, so by doing this, you will have the new severity. The severity, instead of 10, they already go down to 4. It means that if you have a spare tire inside your trunk, probably you do not stranded too long. Probably instead of 3 hours, you only stranded for probably half an hour. Okay, so severity will go down to 4. Then occurrence still maintain, okay, 2, and the detection still 3. Okay, you multiply everything, 4 times 2 times 3, you will get 24 for RPN. Okay, instead of just now you have 60, now you already bring it down to 24. Okay, let's say you want to bring on the down the detection number. Okay, probably your recommendation is to I don't know, probably to put a sensor, probably a pressure sensor. So this will make your detection method easier. So instead of 3, your detection method will go down probably to 1. So 4 times 2 times 1, it left us with the RPM with 8. Okay, instead of 60, you already bring down the RPM to 8. Okay, by doing what? By doing the action of first you carry the spare tire, another one you put the sensor, the pressure sensor for the tire. Okay, so this is a good tools, okay, to, you know, to analyze your PM, to analyze your PDM, to analyze your problem using RCA, okay, root cause analysis. You can always use this FEMA. Okay, okay. So we already go for RCM, go through for RCM and also the FEMA, which is a good tools to support your PM and also your RCM. Okay, okay. So more or less, I'm already finished on the surface of the, you know, the big things about PM, how you produce it through RCM, and try to get predictive as much as possible, and how you analyze it, how you prioritize it using FEMA. Okay, so I guess I'm open for Q&A question. Okay, should you have any question, not just for PM, anything about asset management. Okay, if I could not answer it, I will find it for you. Probably later on I will give you an answer. Okay, if I can answer it, I answer it right now.
Okay. 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 Okay, thank you Cik Suhaimi. So everyone, kita dah sampai ke penghujungnya. Siapa ada soalan boleh type di chat box ataupun boleh request speak kat sini. I boleh approve. Ada sesiapa?
Okay, there is some questions. First from Mr. Kaldip. Okay, how do we look into designing checklist for PM? Okay, thank you, Mr. Kaldip. Checklist for PM is probably the level 4 document. Okay, this is a level 4 document. First, as I said before, as I said just now, first you need to go for RCM process first. Okay, to ensure that what you have is actually the pure list of PM that you need to perform. It means that there is no other way to perform maintenance other than PM. Okay, but if there is a way to perform, I mean, there is another way by using PDM, you will not go into PM. Okay, because why? Because first, you will waste the money. Then you will waste the time and also the manpower. Okay, that is the first what you are going into. You need to revise back your maintenance regime, perform the RCM, ensure which is PDM and which is PM, and then you have a solid list of PM that need to be done. Okay, and then you come up with this proper period when to do the PM. Of course, you will select a proper time, like a turnaround time, like shutdown time, or you have 3 monthly things, monthly things, annually things, okay, then only you decide the period for preventive maintenance. Okay, then you have the checklist for each of the PM. Okay, the checklist is a level 4 documentation, it will come last. But first and foremost, you must come up with your RCM analysis first and ensure this is the solid PM that I'm gonna have. Okay, what do not belong to PM will go into the PDM section. Okay, Mr. Haris. Okay, back to the PF curve. What does the label mean? Example, vibration analysis. Do you mean you can only detect the level of failure with vibration analysis only? Okay, Mr. Haris. Vibration analysis. Okay, this is the example of vibration analysis. Let's take one example, a bearing failure. A bearing failure can be detected by using 5 sense. Okay, people probably can go and touch the bearing and it's too hot to touch. That show the bearing in the problematic stage, or there will be a sound from the bearing. Okay, but the problem is if the bearing is too hot to touch, and there is a abnormal sound that can be heard by your ears, it's too late. Okay, by that time, the remaining life of the equipment probably have only 30 to 40 to 50% at most. But by using vibration analysis, you can detect the problem earlier. Why? Because vibration analysis will detect the initial bearing failure stage. Okay, when you start to hear the bearing by our ear, it's actually too late because the bearing failure at that stage probably produce the sound of probably 10 kilohertz to 15 kilohertz. But when we talk about vibration analysis, the vibration analysis can detect the bearing failure up to the 20 kilohertz frequency level. Okay, so you detect it earlier compared by using the 5 sensors. Okay, so if you detect it earlier, means that your remaining lifetime is still good and more than that, more than using 5 cents, probably 70 to 18%. Okay, so by doing vibration analysis, you can ensure the planning of the shutdown is good, the component planning, the procurement side, and you will ensure there will no sudden breakdown. Okay, that is about what about the PF curve whole about. Okay. It's not that we detect the level of failure with vibration analysis. We detect the failure earlier with vibration analysis compared to other method. That's what the PF curve is all about. Okay. And if you use ultrasonic, it will go earlier compared to vibration analysis. Okay, so that your remaining lifetime of your equipment is more compared to vibration analysis. I'm just trying to understand the curve and conditions stated. Okay, I'm not asking you the detailed vibration. Okay, I'm asking about the definition and understanding your curve and condition state on the curve. I'm just trying to understand the curve and conditions stated at different level. Okay, let's go back to the curve. Ayu, can we go back to the curve to my slide?
Okay, boleh Cik Sami. Just start balik Cik Sami punya presentation slide.
Yeah. Okay, thank you. Okay, Mr. Haris. So, okay, this is the progression failure. Okay, so I'm still not answering your question. Okay, I'm just trying to understand the curve and conditions stated at the different level. Okay, first you need to understand, let me discuss this, Mr. Haris. So on the y-axis, there is a remaining lifetime, okay, and at the x-axis, there is operating hours, okay. As you can see, there is a section whereby there is a proactive maintenance strategies, predictive, okay, preventive, and also run to fail, which is run to fail is a reactive, okay. So if we perform the predictive, okay, if we perform the predictive, let's take the proactive first. If we perform the proactive maintenance, we kill every symptom, okay, meaning that the percentage of remaining life is 100%. The equipment is in very good condition, okay. But if you go for predictive maintenance, okay, you have a lower remaining lifetime, percentage of the remaining life, okay. It's worse compared to run to fail. Run to fail have the lower percentage of remaining life, okay. On the operating hours, is actually what will happen if you do not perform any maintenance strategies, meaning that by operating hours you will run to fail. As time goes by, you will have a problem with the equipment, probably after 3,000 hours, probably after 10,000 hours, if you do not perform any of these strategies. Okay, so probably you have different kind of view, Mr. Haris. Probably you can share with me. Okay, probably you see something that I cannot see. Probably please share with me. Okay, another question. What is the main cause if bearing temperature is high, even after greasing is done, Mr. Holly? Okay. When we talk about the greasing, okay, how you perform the PM? This is PM job. Greasing is a PM job. Okay, the question is the bearing temperature is high. First, the temperature is high probably not because of the lack of grease. There's a whole lot of reason why bearing temperature is high. Okay, you can have high vibration. Okay, you can have electrical problem. Okay, static discharge. You can make the bearing wear because of the electrical problem. Okay, you can have wrong installation of bearing. Okay, so the whole lot of reason why the bearing is hot. Okay, when you grease a bearing, people will follow the O&M recommendation. They follow the O&M recommendation. The recommendation say grease the bearing every 2 months, which we with the amount of 30 grams. Okay, but the question is, does the grease is actually enter the bearing, touch the bearing, deliver to the bearing? So that is a big question. What happened is the grease stuck inside the tube and not going into the bearing. Okay, so this is the problem with PM. Okay, the manufacturer come out with O&M say that you need to perform the greasing job every 2 months. So that is PM. That's why I said when you go back to the RCM, you will ask yourself, do we have a better approach to grease a bearing by doing the PDM? Yes, you grease the bearing using ultrasonic approach, whereby ultrasonic will give you an indication whether the bearing need to be greased or not. If the bearing need a grease, there is a sound of starvation at the ultrasound level, which is we cannot hear with our ear. So the ultrasonic level will give you starvation sound like, and you know that is when you need to put the grease inside your bearing. Then when you put the grease inside your bearing, you will hear it through the ultrasonic instrument, and you will stop when you get the hissing sound. Okay, so you know that there is no overgrease issue. Okay, because you actually greasing the motor or your pump or whatever in a real time. You can hear it. Okay, so you stop when the grease is enough. So that is the better approach compared to PM, which is PDM. Okay, so this will kill everything. Every problem that could appear for this PM regreasing task. Okay, that's why PDM is very important. Okay, so to answer your question, even greasing is done, temperature is still high. Usually when you put the greasing conventionally, it takes time, 2 or 3 days before the temperature goes down. But if the temperature is still high after 2 or 3 days, there is another set of problem. Okay, probably the lock nut is too tight. Okay, you have a probably vibration inside your bearing, or your bearing already wear. Okay, you need to also see a lot of reason behind it, not just lubrication. Okay, I hope I answer your questions, Mr. Kaldi. Okay, so if you have more question, probably you can contact Ayu. Okay, then Ayu probably will help you on that, and if possible, Ayu can facilitate you, okay, to contact me, or whatever platform that can be used, so that I can help you. Okay, I can help you, or we can discuss. Okay, I'm also eager to get your information, to get your experience, to share with you my experience and your experience with me, of course. Okay. Okay, any more question? Do we have time?
Yes, Cik Suami, kita boleh tunggu lagi. Okay, kalau ada siapa ada soalan lain, boleh nyatakan juga dekat sini. Tunggu lagi. Okay, sementara menunggu soalan, boleh klik dekat ruangan yang kita dah pin message tu, iaitu adalah link untuk kita punya post evaluation form ya, for our webinar class today. Teman-teman boleh klik link kat situ. Okay, kalau tak ada soalan lagi, kita boleh move on to the next slide session. Okay. Okay, tuan-tuan, okay, boleh lihat kami punya promo di sini ya, untuk full class training predictive maintenance. If you really enjoy this webinar experience, especially with Encik Suhaimi session, so we have these 2 days virtual online training. Tuan-tuan boleh tengok pada slides topik-topik yang kita cover. Jika tuan-tuan berminat dengan kelas webinar berbayar untuk kos predictive maintenance ini, anda boleh belajar dengan lebih mendalam lagi, dan full version kelas dengan harga promotion hanya RM499. Dengan harga normal price yang sebelum ini adalah RM699 ya. Kos ini juga tuan-tuan boleh claim dengan HRDF ya. Okay, so sekarang government dah boleh bagi online training, kita boleh claim dengan HRDF dengan harga promo RM499. Okay. Boleh hubungi dengan Ayu dan juga salesperson kita yang lainnya untuk more details. Okay. Okay, Cik Sami, kita dah sampai ke closing. Okay, ini pula kita punya training calendar untuk kelas complimentary webinar dan juga paid class. Okay, kami akan sharekan sekejap lagi bersama dengan slide Cik Suami tadi di dalam grup WhatsApp ya, dengan training calendar virtual learning kami. Okay, tuan-tuan, boleh minta isi registration form ya, kalau sebelum end webinar ni nanti. Okay, Alright, thank you so much, Cik Suami, and congrats
Okay,
to all,
thank you. Yeah.
and congrats to all our participants that attend this webinar class today.
Yeah.
Okay, boleh follow our social media platform ilearnic Asta di Facebook, Instagram dan LinkedIn dan juga YouTube untuk video-video webinar kelas kami yang previously. Okay, Cik Suami, sebelum Ayuna end, boleh bagi kata-kata penutup ataupun conclusion for this PM today.
Okay, thank you very much, especially to Mr. Haris, a lot of questions. Thank you very much, Mr. Kaldip, then Mr. Nazman, okay, and everybody. Thank you very much. Should you have any question, you could always contact Ayu. So Ayu will try to, facilitate your problem. Okay. If you have any thing to discuss also, we hope you could contact Ayu. And Ayu, please, if they have any question later on, I hope you could connect them to me, especially the questions. Okay, I want to answer the questions. You give the questions to me and we'll answer back to you. Probably now they do not have the question. Later on they have a question. I hope you can facilitate this, you
Sure, Encik Suami.
Okay.
Boleh,
So,
kalau
yeah.
ada soalan lagi yang tak terjawab ataupun ada more details, boleh bagi pada kami dan kami akan reachkan pada Cik Suami, ya.
Okay, so thank you very much, Shalini. Thank you very much, Ayu. Thank you very much, everybody. Okay.
Okay, thank you so much, Cik Suami. Okay, terima kasih semua for joining us today. Okay, today till next time we join you. Okay, terima kasih semua. Kami akan bagi full slide di WhatsApp dan juga ada email. Okay, jangan lupa boleh join kami punya next session untuk free webinar class. Okay, for more technical course, ya. Okay, thank you. Assalamualaikum semua. Terima kasih.